You heard these arguments from flat earthers that you couldn't answer.
Yeah.
That's because you didn't know the answers. I know the answers. I haven't encountered an argument yet I couldn't refute.
So how do you have gas pressure without a container? Nothing? Danny Faulkner, PhD astrophysicist.
Mr. Vachaspati, or Dr.
Yes.
Vachaspati, he's recommended. So I've come to 2 or 3 of these cosmology colloquiums,
Yeah.
and I've asked these 2 questions, and he's recommended that I ask a cosmologist these questions because
Okay.
the physicist prior could not answer them.
Okay.
The first question is, and this is perfect because you do tests of gravity.
Yeah.
What experiment have you come up with that, or have you discovered or seen that evidences the existence of a force called gravity, which as distinct from the effects of density and buoyancy in a medium?
What evidence there is for gravity?
In the experimental. As distinct from the effects of density and buoyancy in a medium.
The fact that planets move around, lots of evidence.
So I meant experimental evidence. So
That's experiment.
what's the independent variable in that experiment?
Okay, I guess you could look at different
Or control.
samples. I mean, you can drop things in the vacuum.
So things are more dense than zero. I mean, so a vacuum there's a zero medium, so everything's
You can
equally
drop
more dense.
objects.
As
You
distinct-
just take a room,
Yeah.
evacuate the air, and drop
Right.
things, and then they all fall the same.
Equally more dense than nothing, right? They're both equally. So that's distinct from the effects of density and buoyancy.
Yeah.
So gravity is a force that's
Yes.
it has nothing to do with density and buoyancy, right?
Yes.
It exists there whether or not.
Yes,
Right. So when things fall in a medium,
Yes.
it's because they're equally more dense than nothing. In a vacuum, they're equally more dense than nothing. That's why they fall at the same rate. So the question is more as distinct from the effects of density and buoyancy.
Yeah.
If the answer, if no, that's fine too.
I'm not sure I can add more than I said.
Then the second question
Yeah.
is, so your cosmology depends upon. So the second law of thermodynamics stipulates that you can't have a gas pressure system in the midst of a vacuum. Like a high pressure always goes to low pressure.
Yes, that's true.
So has it been brought up within the field of cosmology that the heliocentric cosmology depends upon a violation of the second law of thermodynamics?
What is a heliocentric? Is it
The heliocentric model being
around the Earth?
heliocentric means, or let's say the cosmological model assumed within the parameters of the general relativity theory, whatever you decide is the center of the universe. But you have gas composed stars in the middle of a vacuum. So
So yes, you're right. So if you have gas, it would
Right.
expand into the vacuum. Absolutely.
So do you know of any demonstrations of gas pressure in the middle of a vacuum without a solid barrier between the two?
No.
So would it be true to say that the cosmological model that underpins the assumptions of the popular cosmology, whatever it is, depends upon a violation of the second law of thermodynamics, which is
No,
not demonstrable?
because there is no. It's not like we're putting. First, the universe doesn't have a center,
Well, yeah,
infinite.
sure. Whether center or not.
and it's uniformly filled with radiation. So it's already equilibrated. So the gas has distributed itself throughout all of the volume of the universe.
Okay, so is that possible to demonstrate, let's say, gas pressure adjacent to a vacuum without a barrier between the two? Is that demonstrable in any way?
I'm not sure.
Let's say I have a
understand the meaning.
pressurized shoebox inside of a vacuum. I poke a hole inside that shoebox. Is there any way to demonstrate air not going into the vacuum and staying inside the box, as opposed to?
I don't think so. As you said, I think you're absolutely right. If you poke a hole, it will go out. I know. I can't think of unless you just put the shoe inside a very dense, much denser gas or something like
but
that, or
would
put it
not be
inside
viable, right?
like water or something. I don't know.
So it's true to say you can't have gas pressure in the midst of a vacuum without a solid container.
Yes,
Okay, so how is it the case that we have atmosphere on Earth without a solid container?
because it's attracted to the Earth.
Via gravity,
By
right?
the gravity.
But why doesn't gravity hold air in the shoebox?
Because the shoe doesn't have enough gravity.
The Earth presumably does.
Earth has a lot of gravity.
The Earth is
shoe,
inside.
and the shoe doesn't.
So why doesn't Earth's gravity hold the air inside the box?
Because, sorry,
Why doesn't Earth's gravity hold the air inside of the shoebox, which is in the midst of a vacuum?
because the gas has pressure. So it has pressure and it just
It just goes out into the vacuum.
Sorry,
I'm just saying.
I have people waiting and I need to go.
Got it. All right.
You think supermassive